Now this equation is called as equation 2. So this is also equally important, but it's not difficult to remember. So once the first equation is by hearted, so in a medium, what happens? The equation becomes 1 by 4 pi epsilon, where epsilon is called as what? Permittivity of the medium. Permittivity of the medium. Now, easily the answer can be obtained for the question why the constant here epsilon naught permittivity of free space or permittivity of air or vacuum, and here permittivity of the medium, why they are called as permittivities. The reason for this is this constant only decides the ability of the medium to permit force between the charges. Now take a medium of high value of permittivity placed between the 2 point charges. If the permittivity value is very high, then automatically it means that force is low. That means the medium does not allow the much force to act between the 2 point charges. So this constant epsilon naught, epsilon that is present here in this particular equation, is actually deciding the force between the two charges. How much force it permits to act between the two charges, that is decided by the constant epsilon. That's why it has been called as permittivity of the medium. So it's something related to the ability of the medium to permit force to act between the 2 point charges. If epsilon is high, it permits only less force to act between the 2 point charges. Observe the cursor compulsorily, everyone. So if epsilon for the medium is low, the medium is permitting only epsilon is very low, it means force will be very high in that particular medium. Force between the 2 point charges will be very high if epsilon is very low. If epsilon is very high in that medium, force between the 2 point charges will be, epsilon is very high, force between the 2 point charges will be very low. So it permits very less force to act between the 2 point charges. So that way this epsilon is some property related to the medium which permits force to act between 2 point charges. That's why it has been simply called as permittivity of the medium. So that way the name permittivity comes. The higher the epsilon, lesser the medium, lesser force the medium permits to act between the point charges. The lower the epsilon, the more the force permitted by the medium to act between the 2 point charges. So that's the reason why epsilon is called as permittivity in the denominator of the expression for force. Epsilon is the permittivity of the medium, epsilon naught is the permittivity of free space. So this is the other equation. So whatever things we are seeing here are very simple. So permittivity of the medium mainly depends upon what? The nature of the medium. Then does permittivity of the medium depend upon the variables? The question for this is, for example, if you have a fixed medium, in that fixed medium, so whether it is air or vacuum or any other medium like a glass block or anything, in that particular medium, will the permittivity constant be depending upon the variables? The answer for this is no. Permittivity of the medium, a given medium, will never depend on the variables. The reason for this is permittivity actually belongs to what? It belongs to the proportionality constant. So we are calling the proportionality constant as what? C dash, say. Always a proportionality constant. Just see here this equation. Y is equal to kx. K is called as a proportionality constant. Why it is called as a proportionality constant? The word proportionality comes from because this particular quantity k is actually is related to, it's something belonging to the equation in which two variables are proportional. That's why it's called as a proportionality constant. So that's the reason why it has been called as proportionality constant, because it's something related to the proportionality relation between two variables. Then why it is called as a constant? The reason for this is called a constant because it never depends upon the changes in these two variables. How it does not depend on the changes in the variables. It can be understood like this: if x is doubled, y gets doubled. Just see here this equation also. Observe the cursor compulsorily. If x is doubled, y gets doubled. X is tripled, y gets tripled. X is halved, y gets halved. But in all the cases, is k changing? No, k is not changing. That's why it is said to be independent of the two variables, and it's said to be a constant related to the proportionality relation between two variables. That's why the name proportionality constant comes here. So k is called as proportionality constant. There are two reasons. One is because it's something related to the proportionality relation between the two variables, any two variables, and It is independent of the changes in the variables. Even if the variables are changed also, constant will never be getting disturbed. So that's the thing. So a proportionality constant always independent of the variables. So here also, just see here. So whatever things we are seeing here are simple, nowhere any complication is there. Everything in science and technology has a reason. It has a definite reason. Now that reason is the most important thing. It should be understood clearly. Any doubt is there, once again you just check that particular step once again very clearly. It can be understood. Each and everything can be understood by using very simple definitions. Very simple laws. Each and everything in science and technology, even mathematics is also a science only. It is also based on very simple definitions and very simple laws. Mathematics is called as science of numbers. Physics is called as science of non-living things. Biology is called as science of living things. Chemistry is called as science of elements and compounds. So everything is a science. Always science depends on very, very powerful definitions and very, very powerful laws. Everything in science and technology can be understood using the scientific definitions and fundamental laws. So the only thing is you must put some little effort and you must spend some little time. It will not take much time. Everything becomes very simple once a definition or a fundamental law is applied in science and technology, including mathematics. No complication will be there. Okay, so always the proportionality constant is independent of the variables. So even if the variables are changed, it will never be changing. X is doubled, y gets doubled. X is tripled, y gets tripled. But constant always remains the same. So now considering this proportionality relation. So this proportionality relation, f is proportional q1 q2 by r square, or f is equal to c dash 1 by 4 pi epsilon can be called as c dash into q1 q2 by r square. If these variables q1 is doubled, f gets doubled, q2 is doubled, f gets doubled. So r square is doubled. What happens? R square is in the denominator. So r square denominator gets doubled means what happens? The value force will be getting halved. So always just this is very simple. So I'll just draw another rough column here. Just see here. So rough columns are very, very important because they give the reasoning steps. They give the reasons why we are getting the step in the derivation. So derivation will be completed here in this topic. Here itself will be completed. But the reasoning steps always will be coming again and again. This lesson, next lesson, another derivation, every derivation, same reasoning steps will be coming. So they are the most, they are even more important than the actual derivation. Without the rough column steps, without the reasoning steps, derivation can't be understood. Once the reasoning steps are understood, not only this derivation, each and every derivation in science and technology can be understood, including mathematics. So now you take an inverse proportionality relation. Y is inversely proportional to x. So if x is doubled, y actually gets halved. X is increased, y gets decreased. If x is doubled, y actually gets halved. It can be easily proved from this particular equation. You can just test it. You can easily prove it. Try to prove it. Very easily it can be proved. It can be understood. Any doubt is there, you can just discuss with your friends or again ask your faculty. Very easily it can, or just refer a textbook if anyone is not available. Very easily this can prove. The thing is you have to prove it. If x is doubled, y will be getting halved. Just check it. It's easy to understand. If x is increased, y will be getting decreased. Just check it. It can be easily understood. So now if r square is doubled, actually what happens is force will be getting halved. If r is doubled, double means it will become 2r. 2r whole square is what? 4r square. So denominator is becoming 4 times. That means force will become 1/4 actually. Denominator is increasing 4 times. 4r square it will become. So force is becoming 1/4. That way it's actually getting affected by distance r. So now the important thing is if the variables are changed, force is changing. This variable force is changing, but proportionality constant will never be changing. So now already we got that this proportionality constant 1 by 4 pi epsilon, or the epsilon itself, is depending on the nature of the medium. Clearly for different media its value is different, but it is independent of the variables q1, q2, r and f. That means it depends only on the nature of the medium. So that is a very, very, very important property of permittivity of the medium. It depends on what? Depends only on nature of the medium, but not depending on the variables charge, that is charges, the two charges, distance and the force. Depends only on the nature of the medium present between the two charges. But medium nature depends on its temperature also. because a medium, when temperature is changed, for example ice, when its temperature is changed, after some time what happens, if it's heated, it will become water. So then it will have some other value of permittivity. Once it becomes a gas, water is heated, it becomes steam, again it's what is happening, permittivity will be changing. Any medium can be considered between the 2 point charges. So it is not just depending, not nature of the medium it depends, means along with the actual nature of the medium, it also depends on the temperature of the medium also. So it's not a separate factor, it's actually included in the nature of the medium itself, but it should be mentioned. That's very important. Even if slight change in temperature also, it is found that to some extent the proportionality constant, the permeability of the medium epsilon or 1 by 4 pi epsilon, complete constant 1 by 4 pi epsilon naught will be changing. So these are the things related to the permeability of the medium. So whatever things we are seeing here are simple, nowhere any complication is there. So now consider another small thing, the units. So this is about the Coulomb's inverse square law complete explanation. Now what about the units of permittivity or units of permittivity of free space? Already we have seen that the units are Newton meter square per Coulomb. How we get this? 1 by 4 pi epsilon naught or even 1 by 4 pi epsilon, units will be Newton meter square per Coulomb square. How we get this? From the equation for force. Just see here, force is 1 by 4 pi epsilon. We'll take the general medium. If it is air or vacuum, we have to take epsilon as epsilon naught. So 1 by 4 pi epsilon q1 q2 by distance square. Now from this, what will be 1 by 4 pi epsilon units? It will be, so 1 by 4 pi epsilon equation can be written first. Once equation for a quantity is known, units can be easily obtained. For example, area is length into breadth. Length unit is meter. Breadth units meter. Length into breadth means units will be meter into meter. So from the equation always units are obtained. The equation for 1 by 4 pi epsilon is what? Fr square divided by q1 q2. So from this, what will be the units? Force unit is Newton. Distance unit is R is meter. Distance square means meter square. So denominator is Coulomb into Coulomb. So by Coulomb square. So these are the units of 1 by 4 pi epsilon. Now from this, what will be the unit of epsilon? Epsilon will be what? We can get the equation for epsilon again. Epsilon will be what? Take epsilon to this side. Then it will be what? Q1 Q2 by 4 pi Fr square. Epsilon, just see here, observe the cursor. Epsilon I will take to this side and take Fr square Q1 Q2 to the left hand side. It will be what? Epsilon is equal to Q1 Q2 by 4 pi Fr square. Q1 Q2 is what? So I will not write the complete equation. Directly equation units can be written. Unit of epsilon will be what? Epsilon is q1 q2 by 4 pi Fr square. So q1 q2 means Coulomb square by 4 pi. 4 pi has no units. Fr square will be Newton meter square. That way the units of epsilon can be obtained. This way you very easily the units can be obtained. So they need not be exactly by hearted. So the method should be by hearted. Method is very simple. First we are getting the equation for 1 by 4 pi epsilon or the equation for epsilon. From that the units can be obtained. So if you want to by heart, you can by heart it also, no problem, but it's not compulsory. So method should be by hearted. So this method from the this particular equation, Coulomb's inverse square law is easy to remember. This equation is really very important. So I'll do one thing, because here units need not be by hearted. I'll just put it as slightly less important. Less important means it's not like it will not be asked in the exam. It need not be by heart. 3 star I'm putting means I'm just putting 3 stars only that for the things to be by hearted. So this is something not to be by hearted. I'm just putting it as like 2.5 stars. Half star is not possible to draw. I'm putting a spot here, circular spot, 2.5 stars. 2.5 stars means if you can by heart, you can by heart it. Otherwise, not required. Just from the equation, it can be derived. So this is the equation which is really to be by hearted Coulomb's inverse square law equation, from which the units can be very easily obtained. So that's the thing about the units of epsilon naught or permittivity of a medium. So this also I'm putting 2.5 stars. Only the equation to be by hearted. So that's the thing. So running notes is almost same, not much different. Now how to complete the running notes? So it's so always I said I'll give little time for writing the running notes. So almost not much change will be there. Only in the previous page. Just see the previous page here. Okay. So very quickly the running notes can be completed. So we'll just go to the previous page. Actually the first definition also I did not give the running notes. I said I'll give 5 minutes time for writing. Within 5 minutes the entire running notes can be completed. because only the explanation is understanding of the explanation of the derivation, understanding of every step of the derivation is important. Once it is understood, running notes will be very simple. So now at a time the entire running notes can be taken. So actually the topic is completed. The explanation of the Coulomb's inverse square law is completed. Already we have seen it's mainly a 3 marks question. So we'll just I'll just take the previous page. So this was the previous page. See the Coulomb's inverse square law. It carries 4 marks to 3 marks, 4 marks to 2 marks. So I'll just write it more clearly. 4 marks, 3 marks and 2 marks also. Already I said this before. So 4 marks it's never given. So into means it's kept a wrong like thing symbol here. 4 marks it's never given. It's only given for 3 marks or 2 marks. So 3 marks questions may not be there for many board exams, but essay questions carry 8 marks to 5 marks in different board exams. So firstly, the theory, scientific theory is actually the derivation is most important. Problems will be nothing compared to a scientific derivation. So many times I have said this, problems are always nothing compared to a real scientific derivation. Problems can be set by anyone. They can be solved by anyone. Real derivations are given only by scientists. None have given the real derivations. Only few scientists have given. So that's the power of the scientific derivation. So in board exam only scientific derivation can be asked. Entrance examination scientific derivations can never be asked because scientific derivations are standard. Even a 6th class student can by heart a scientific derivation and write it in the exam if an entrance exam the derivation is asked just for getting the free seat. So that's not proper. So only numerical problems are given. The reason is by changing any two numbers, answer will be changing. Nobody can guess what is the correct answer except the person who is solving the problem. So that's the advantage of giving numerical problems in entrance examinations. Only with sufficient full understanding is not required. Just sufficient understanding, intelligence is sufficient, sufficient intelligence. But intelligence is nothing compared to the actual hard work or hardworking character. That is what is required for the understanding of the scientific derivation. Just ordinary plain intelligence is sufficient for solving the problems of the entrance examinations, whereas real character is required for understanding, inventing scientific derivations. That was done only by few scientists of the world. So that's the power of scientific derivation. Only in the board exam they are asked. So in full detail, the answer should be written in the board exam because each and every step carries some marks, half mark, 1 mark, 2 marks like that. So now coming back to the first page. So electric charge. So already just see here. We stopped here. I said we'll complete the running notes quickly. So we are coming back to the page 1. So just see here. So whatever things we are seeing here are simple. Nowhere any complication is there. Now just see here. So electric charge Q definition. So symbol is Q. So I'm just putting symbol, writing more symbol more clearly. Q, this is the symbol. So no marks because it can't be asked in the exam. So examination syllabus actually starts from. So these also syllabus only. Law of conservation, 2 types of everything is syllabus only, but they can't be asked directly. Even as 2 marks questions also, but they'll be useful in the other topics. So from here onwards, the real marks topics start. Coulomb's inverse square law of electricity, or it's also called Coulomb's inverse square law of electrostatics. There's another Coulomb's inverse square law in magnetism, and similar to Coulomb's inverse square law, there is another law which you already studied in the gravitation. Newton's universal law of gravitation also is an inverse square law. Gravitational force inversely proportional to square of the distance between two masses. So all of them are inverse square laws, but Coulomb's inverse square law, there are 2 Coulomb's inverse square law given by Coulomb himself, by the scientist Coulomb himself. One is electricity, one is magnetism. So not only force exists between 2 charges, even magnetic poles also force exists. That also follows Coulomb's inverse square law. Both laws are simply called as Coulomb's inverse square law. One in electricity and the other is in magnetism. Okay. So electric charge Q. It is just quickly write down. So already I said compulsorily you have to take the notes in running notes in the classwork itself, because a video should not be watched second time, because video all the details explanation will be there, each and every it will take long time, only once it has to be listened, and each and every detail main point should be taken down in your running notes. So video, you just observe it takes 1 hour. A running notes page to take down, it will take only 5 minutes. Next time when you're revising the topic, in 5 minutes you can revise if you are not watching the video. So second time video should not be watched. I said this many times. So only every time when you are writing the weekend exam, when you are preparing for the weekend exam or monthly exam or quarterly exam or final exam, every time the same running notes. One page will be there for the topic. One page you have to revise. Just 5 minutes it will take. So electric charge. What is the definition? Already we have seen this. It is the, so very quickly I am writing. So what I am pronouncing, you have to take it quickly. So what I am writing, don't see, because don't try to write from what I am writing on. Don't think that just like sixth class students I am writing on the board. So it's not like that. So I am writing this for the sake of orderliness. So what I am pronouncing, like dictated notes you take down, and every word, 2 3 words you are writing, just check it back, come check back on the, check it from the board also, whiteboard also, that is on the screen also, so that by chance any words you have missed also, it will be very clear. So spelling may not be clear because I'm writing very fast, at the same time it should be taken, because don't think that I'll just take the snapshot of the entire page after running notes is complete, then later I'll take, later it can't be understood because I'm writing very quickly. Only what I am saying can be understood, what I am writing, along with hearing. If you are watching the sentence you can understand it, but later everything will be mixed up, congested, it can't be understood. So again you have to hear it, any sentence not clear, it's, you have to again watch the video again 2 minutes back, all that rewinding, all that should not be done, it is unnecessary time waste. So now itself you have to take the running notes, and next time onwards always any derivation, scientific derivation step, each and every step is important, each and every step you have to be revising, always you have to be revising. So revision of a scientific derivation always, it produces very good understanding, very good results it produces. It even improves the brain power also, because scientific derivation was given by great scientists. They followed a certain order using different laws, different definitions. So that order will get revised, the brain becomes very sharp. It's much better than doing the numerical problems again and again without proper understanding of the derivation. It's without derivation and numerical problem is solved means it is waste. Only that particular problem can be solved. If problem is twisted, some other point is mentioned means gone. It's not possible to solve. So by proper understanding of a derivation, not just one problem or 10 problems, infinite number of problems, any number, any type of problem can be solved. So that's the importance of a scientific derivation and a scientific definition. Scientific derivation is based on only simple scientific definitions and the laws or principles. Coulomb's universal square law, Gauss law, Newton's law, etc. Simple laws of that particular lesson it is based upon. So that is the importance of a scientific derivation. So coming back here, so as I am writing quickly, at the same time you have to take down the notes. So running notes should become, once I complete writing the last sentence on this page, you also should be completing at the same time, because later everything will be congested here. All the entire page will be congested. So many letters, so many sentences, so many things, rough column, fair column, everything will be mixed up. So it can't be understood later. So it is the electric charge. It is the property. So just see here, it is the property. I'm just moving it a little up also. So here, just observe the diagram just as a revision. So this is the comb. So when the comb is rubbed by this cloth, just observe the cursor compulsorily. What I am explaining. This is the comb. Once this comb is rubbed with the piece of cloth, this is a piece of cloth. What is happening? Electric charge is formed on the comb. Because of this electric charge, so plus denotes a positive charge. Because of this charge formed on the comb can attract these bits of paper. This is one bit of paper, this is one bit of, so you can just see the force also, force of attraction. So this property, charge, when it's formed on the comb, makes the comb attract the bits of paper or bits of other substances. So that property itself is electric charge. That was the definition which you have seen earlier. It is a property which, see here, which I am writing congested manner, but I am pronouncing it clearly. It is a property which, when established on an, which when established on an object, establishments formed, so the charge is formed, this property called as charge is formed on the comb, which only makes the comb attract the bits of paper. So it is a property which when established on an object makes the object attract, not just attract. Sometimes even these bits of paper, once they get attracted again, they'll be pushed back again, they'll be repelled back again. So this is a positive charge comb. Supposing another positive charge paper is brought, it will get repelled. So why means because of this positive charge formed on the comb. So this property which is formed on the comb itself is called as electric charge. So it is a property which when established on an object makes the object attract or even repel. Makes the object attract or repel other objects around it or near it. Near it will be even better. So other objects near it. That means when they are brought near it. That means near the object, near this object. It means here the object. So that's the simple definition of electric charge. So very simple definition. So SI units, Q is the symbol for electric charge, Coulomb. Coulomb is the SI unit. How Coulomb is defined? Actually, the definition of Coulomb also comes in the Coulomb's inverse square law only. Little later it will be coming more clearly. So two types of charges. So which are the two types of charges? Positive and negative charge. So these are the two types of charges. Already we have seen. So if positive charge is formed on the comb, then on the cloth, a piece of cloth, a negative charge will be getting formed. Always this is the rubbed. Comb is the rubbed substance and piece of cloth is the rubber. Rubbed and rubber. Always it has been proved that the rubbed and rubber will develop equal and opposite charges. This is a very important thing that happens in when an object is actually charged by means of rubbing. Both the rubbed and rubber will develop equal and opposite charges. Comb is developing, rubber is developing positive charge, means rubber will develop equal and opposite negative charge. This is plus 10 coulombs, this will be minus 10 coulombs. By chance, if it's not a comb, supposing a glass rod is taken, then a glass rod, when it's rubbed by some other substance, if it develops a negative charge, that means rubber is now becoming negatively charged if it's like a glass rod, and the rubber will become positive charge. Again, it will be equal and opposite. So this is very important thing. So this is the explanation of the two types of charges. So no explanation is required here. So positive and negative charges, that's all. See here, positive and negative charges. These are the two types of charges. So no explanation is required because it will not be asked as a question in any form. So next, law of conservation of charge. This is a very powerful law. It's a fundamental law. So already you have learned about conservation of mass and energy. So this is the third quantity, conservation of charge. Statement, already we have seen this. So the same statement should be written. So this is a closed system. I have drawn this rectangle to indicate a closed system. So it's actually not required. So there is no place here. Already we have covered this. So if required, I'll draw it again. So for present, I'm just removing it so that the statement can be written very quickly. So the total charge in a closed system. That means closed system means like a closed room or a closed enclosure, like that. Total charge in a closed system remains constant, just like total energy remains constant in a closed system, total mass remains constant. The statements are identical whether it's conservation of charge or mass or energy. Total charge in a closed system remains constant and charge can neither be created nor destroyed, but just like energy can neither be created nor destroyed, or mass can neither be created nor destroyed. So law of conservation of charge, law of conservation of mass, and law of conservation of energy, the two conservation laws of mass and energy already have learned in the 6th class itself. Charge you did not learn there much. So you have learned the law of conservation of charge most probably in the 10th class. So this is a simple statement. So the statement here also, it's very important. So charge can neither be created nor destroyed, but can only be transferred from one body to another body. So what is the meaning of transferred from one body to another body? It is simple to understand this. So near this positively charged comb, supposing you are bringing another uncharged comb from the positively charged comb to the uncharged comb. Uncharged comb means which is not charged yet. It carries zero charge. So when the uncharged comb is brought into contact with it, so a part of this positive charge will be transferred to the uncharged comb. That also will become positive charge. That's called transfer of charge. So later we'll be seeing this more clearly. So now it's not much important. Only the statement understanding is important here. Conservation of charge. So next, now the real syllabus topic, Coulomb's universal law statement. This also already we have seen. So quickly write the statement. The electro, so electro it is. Write it more clearly. The electrostatic. See here the words later. If you are writing this, it will not be clear. So just one small thing here. So electron. This is another rough column. Just see here. Always compulsorily you have to take the rough columns also as neatly as possible. This is another rough column. Just see here. Three fundamental laws of the universe. Already we have seen. There are only three fundamental laws. They are actually sets of fundamental laws. First law is a set of three laws, Newton's laws, first, second, and third. Second fundamental law is again a set of three laws, conservation laws, mass, energy, and charge. Third is Einstein's principle of mass energy equivalence. These things also you have to write compulsorily in the rough column. So actually there is no place here for rough column. So I have drawn a small rough column box like thing and written here. This is the rough column for charge of an electron or proton. E denotes charge of an electron or proton. Electron charge is negative minus E. Proton charge is plus E. So this as it is you can take it. So in brackets with a pencil you write this is electron charge, this is proton charge. This will be very useful later in solving problems. This is a very simple thing. There appears to be nothing here but very useful for solving problems. Charge of an electron is minus E, charge of a proton is plus E. So in brackets you just write here electron and here proton. In pen, with pen also you can write, no problem. You not write just with pencil. Always rough columns you have to be writing the reason. So I am explaining some reasons related to the syllabus. Supposing you get a doubt, that also you try to find out the reason. If you find out the reason, you write that reason in a by making your own rough column, but write with pencil because sometimes you'll get some more points. Then you have to make adjustment in this first reason. So you have to erase. You can erase it if you're writing with a pencil. Supposing I am writing with pen, the reason is already I found out these things from different books. So I'm writing it exactly as it is. They were given by scientists, so we are following that. So they have not been changed for hundreds of years. They were invented hundreds of years back. Even now they are correct. But always we have to be finding out reasons and some ideas will be getting. Immediately you get an idea, you fill it with your rough column. Draw a rough column and write the reason with a pencil. Sometimes you find another reason, you can make an adjustment in this and write that extra point also with a pencil. Always whatever you are writing in the rough column you have to write with pencil. Whatever you are taking in the class from your teacher you have to write with a pen because your teacher gives them from books, different books. So already they were verified by scientists, so they will not be changing. So the electrostatic, so coming back here statement, the electrostatic force, see the spelling force, it's between 2 point charges, you have to write faster, between 2 point charges is, I'm just making a box here, the electrostatic force, actually here this and that are mixing. So right hand side page and left hand side page are mixing, so I have separated them by drawing a line here, this line. So electrostatic force between 2 point charges is directly proportional. Just see here, the electrostatic force between 2 point charges Q1 and Q2, which are separated by distance r, is proportional to the product of the charges. And just see here the equation, cursor, always compulsorily you have to see the cursor. With what I am explaining, the equation or step or diagram which I am explaining, I am showing by means of cursor. Just see this pen-like form. So just here at the letter F I kept the cursor. It's in the form of a pen. because on this whiteboard the cursor is actually used as a pointer, so it's in the form of a pen, because the same cursor is used for writing on the whiteboard. So it was designed by like this on this particular app, paint app, Windows Paint app. So the electrostatic force is directly proportional to the product of the charges and inversely proportional to the square of the distance. That itself is a statement. The electrostatic force between, again coming back to the statement, so you have written already at the first three lines, the electrostatic force between 2 point charges is directly proportional to the product. Product means what? Multiplication. Product of sum means addition, difference means subtraction, product means multiplication, quotient means division, like that. So electrostatic directly proportional to the product of the charges, one is q1 into q2, and inversely proportional to the square of the distance. So here actually space is over, actually diagram is coming here. So what I'll do is I'll just because on the Windows Paint app actually the equations can be actually moved. So this diagram actually I'm moving down, but already you have drawn the diagram in the class. So supposing you don't have place, it doesn't matter, you just put a dash here, and below the diagram you just continue the definition, it doesn't matter. Actually diagram comes under explanation after the statement, so it doesn't matter. After the diagram you can just continue the statement, after that you put an explanation, and in the explanation you just put figure. That figure is nothing but this figure itself. That way small adjustment, you not strike off the diagram, all that is not required, but see that some one, at least one or two lines are between the what you have written under statement and the diagram. So like this, just see here, already everyone has taken this during the explanation itself. If you did not take there, doesn't matter, you can take it now. So like this, just two lines, see here, two lines, see the cursor, it's in the form of a plus here, the cursor now, because I'm just using the selector rectangle here. Now the cursor has changed in the form of a plus here, plus sign. So two lines are there, like that neatly you can just clearly you can maintain a difference between the statement and the diagram, because diagram is a different thing, it comes under explanation. So here on the app there is no problem, so because already you are writing this on the paper in the notebook, doesn't matter, you can't change the diagram, push the diagram down, so doesn't matter, leave one line, two lines between the statement, what you have written in the statement and here, and after the diagram you continue this. So and inversely proportional to the square of the distance between them, between the charges, that means point charges, and acts, the direction of force is exactly along the line joining, so it always acts, force acts on each charge along the line joining the two charges, and acts along the line joining the two charges. So charges, you see here word is not clear, but I have pronounced it clearly, joining the two charges, that's all, this is the statement. So after the statement comes the explanation. So under explanation diagram should be there, but already this diagram I've actually drawn somewhere here, see the cursor, so it doesn't matter, you put explanation and see put figure. So the figure is down here, I'm keeping an arrow, so your figure will be somewhere here, so just put an arrow upwards, that's all. Figure means upward, the upper figure, that's all, that's the thing. So this is the simple running notes of this entire page. So next continuation is, just see already we have completed the entire derivation. So this is a continuation. So f proportional q1 q2 by r square. So this is entire thing, there is no explanation, you see, only equations are there. The fair column, so this is the rough column, just see rough columns are very important, because rough column steps they are again and again applied, not just in this derivation will be ending here, but the method of the derivation is actually present in the rough column. They will be again and again they'll be coming in the other lessons, other topics, other subjects also. Many subjects, many branches of physics are there. And again, applied physics is called engineering or technology. Engineering means it's related to engineer. To engineer means to design. So engineering is nothing but designing of devices, like an instrument, like instruments or machines or anything. Designing an instrument using the principles of science. What are the principles of science? In physics, the main principles are only three. One is Newton's laws, next conservation laws, next Einstein's principle of mass energy equivalence. So using such principles of science, if a device is designed, that designing is called engineering. To engineer means to design. Using the important thing is using the principles of science. That's the power of the laws of physics or laws of science. Every branch of science has its own laws. So physics, these are the three main laws we have seen already in the previous page in the rough column. So now the remaining derivation is as it is. As it is, it should be taken. But just see here, 1 by 4 pi epsilon naught is a proportionality constant. So here it is denoted as simply, I call it as C dash for the sake of understanding. But that's only for explanation. So in the exam, it should not be written. So I'm removing that C dash C here so that it's what is necessary, simple manner it should be taken. So just see here, arrow mark I kept. Arrow mark means it doesn't matter, arrow mark can be used. So it's like the word where epsilon naught is permittivity of air or vacuum. Instead of writing the word where, an arrow mark can be used here. It doesn't matter because the reason is topic carries only 3 marks. So 3 marks means already one statement, one diagram, just 1 or 2 steps. That is sufficient. More than that, it should not be written. So rough column entirely must be avoided in the exam, and actual matter that is present in the fair column should be as small as possible. So everything must be avoided. Most of the explanation should be avoided. So here anyhow there is no explanation. So 1 by 4 pi epsilon naught is what? 9 into 10 power 9 Newton meter square per Coulomb square. Epsilon naught is equal to, from this epsilon naught is 1 by 4 pi into 9 10 power 9 Coulomb square per Newton meter square. So this I'll write a little more neatly. So this is the fair column. So I'm just making it a more neater. So Coulomb, just observe here, Coulomb square per, just observe the cursor here, Coulomb square per Newton meter square. And here this is again the diagram of the previous page. So I have drawn this diagram of the previous page in the rough column here. So I'm just keeping it as rough. This is not required. The reason is this already completed in the previous page. Only for the sake of explanation here I have drawn it. So I'm just mentioning this as rough, but it's not required, it need not be taken. But this rough is very important. This rough step, y proportional x means y is equal to kx. So just see here, y proportional x proportional z, y is proportional to xz. So this is required. Again another rough, y proportional 1 by x. That means y proportional 1 by x means y is inversely proportional to x. That's how it is read as. This is another rough column. All these are very useful because they are general steps. So this is not required, this rough column. So 1 by 4 pi epsilon, from that epsilon naught we are getting. So this is the first equation is applicable for force between two charges only in air or vacuum. So just write here in air or vacuum. This is very important. But in a medium, what is the equation for force? This is the equation 2. So this is in a medium. This is the equation. This is the equation applicable in a medium. So here I'll not put an arrow here. I'll just write this clearly, where epsilon is permittivity of medium. So on what factors permittivity depends upon means it depends only on the nature of medium and temperature. Next, units of epsilon. So this is another thing. So after the explanation this comes. So this need not be written in the question. Supposing explain Coulomb's inverse square law is given, this need not, units of epsilon need not be written at all. So this is the complete explanation. So there is not much change, you see. whatever explanation we have seen in the derivation of the Coulomb's inverse square law, it's not a big derivation, just from 2 or 3 main steps it has. Most of it is values, 1 pi 4 pi epsilon naught, what is the value, all that, units also. So factors, simple factors on which permittivity depends upon. So just a simple manner it can be written. So just for 3 marks this is sufficient. Even for 4 marks also this is more than sufficient, because lot of more than 1 page it has come. So that's the thing. So units need not be written. So wherever the topic is ending, I'm drawing a line, you see here, ending line, ending of the topic. So I'm just drawn a line here. This is the completion of the topic. So that's about the Coulomb's inverse square law. So whatever things we are seeing here are simple, nowhere any complication is there. So running notes, within 2 minutes you complete the running notes and then watch the next part of the video. Till then you put the page, this particular page, you pause the page and complete the running notes. After completing only, you continue listening to the next part of the topic. So this is the completion of the Coulomb's inverse law. After this we have little simple points which are actually obtained from this derivation, but that's another topic. Though it's actually based on Coulomb's inverse law, it's actually comes under separate topic from Mark's point of view. So complete the running notes and then listen to the pause, put the pause here, video to a pause, and complete the running notes and then listen to the continuation of the video.